Hello everyone, and welcome back to If It's Math. Today we're going to be starting the first of our series on real numbers, and topic 1 is going to be basics of number sets. So when we talk about sets, the important thing is that a set is a collection of numbers. So for example, all numbers from 1 to 100 is a set, or all numbers that are divisible by 5 is another set. So that's all number sets are really, sets of numbers. But it can get kind of complicated if you don't know the terminology and the symbols. So we'll go over that today. So when you want to define sets, you use brackets. So this is the first new symbol that we'll look at today. And that's these squiggly brackets. They're a little hard to draw sometimes. But the way that you read that is the set of. So there are two ways that you can write out sets of numbers. The first is a roster method. And with a roster method, you're really just listing out all of the numbers that are in the set. So use those brackets and list out numbers. So 2, 4, 6, 8, 10 is an example of a set using the roster method. The other way that you'll see these is what's called the set builder notation. And so it's sort of written as a rule. So instead of writing out all the numbers, you write a specific rule. So there's another new symbol, and this is a vertical line. It looks a little bit like a 1, but it's that vertical line. And you read that such that. So the way you would write in set builder is A equals the set of all numbers x such that x is an even number. That's how you would read that. So you can see how it's more of a rule than a list. So you'll see both of them used. They have their pluses and minuses. Rosters are good for small sets. So if you have a set that's just 1, 3, 5, 7, 9, it's easier to just write that out in roster instead of trying to figure out a rule. But set builders are good for really large sets of numbers that you just couldn't write out. So for example, A is the set of all numbers x such that x is a multiple of 4. You couldn't write that in roster form because there's just so many. So now that you've got sets, let's talk about subsets. So a subset is a set where every number in that set is a member of another specific set. So you'd be comparing two sets and deciding whether or not one is a subset of the other. So there's two kinds. One is a proper subset. And so a proper subset happens when this set is a subset of another set, but they're not the same set. So every number in this subset is a member of that other set, but that set has other numbers that aren't in that first subset. So here's another new symbol. The symbol that you use for proper subset looks like this sideways U. It's kind of like a curved less than sign. And so that symbol means a proper subset. You can also have a subset or equal to. So you just do the proper subset, kind of like curvy C with a line under it. So let's look at a few examples to see how these subsets work. So let's say A is all the numbers 1 through 10. And B is just the even numbers, so 2, 4, 6, 8, 10. And let's say C is 10, 8, 6, 4, 2. So when you start to compare these, you'll see that B is a proper subset of A, because every number in B is in A, but there are other numbers in A. And then C is a subset or equal to, because they're the same sets, they're just different order. So you can also think about this visually. So we had A as all numbers 1 through 10, and then B was the even numbers 2 through 10. You would represent this as B is a subset of A, a proper subset. Okay, so now let's look at how we can combine sets. So there's two different ways we'll look at. We'll look at unions and intersections. So unions first. When you talk about the union of two sets, it's the set that's made up of all numbers in either or both of two sets. So we've got another new symbol, and this is a U. And so that U just represents union. So then when we look at an example, let's say A is the set of numbers 1, 2, 3, 4, 5, and B is 3, 4, 5, 6, 7. Remember, the union means the set that has members in either of them. So when you do A union B, it'd be 1, 2, 3, 4, 5, 6, 7. You don't duplicate numbers. So the next way we can combine sets is through intersections. So an intersection is the set of numbers that is contained in both of sets that you're comparing. So remember when you did union, it was numbers that are in either. For an intersection, it has to be in both sets. So new symbol is kind of like the upside down of a union. So it's upside down U, and you read that as intersect. So then let's do an example. So let's say A is 1, 2, 3, 4, 5. B is 3, 4, 5, 6, 7. So A intersect B is just going to be 3, 4, and 5, because those are the only numbers that are in both sets. Okay, one last concept we'll talk about, and that is the empty set. It's going to sound kind of strange at first, but just stick with it. So an empty set is a set that has no numbers. And so you might think that's not very useful, but you'll see why you need to have a symbol for that in a minute. So the new symbol for that is a 0 with a line through it, or it's actually an O, and that just is read as empty set. So let's see why we need to know that. So let's say A is 1, 3, 5, 7, and B is 2, 4, 6, 8. If you're asked to find the intersection of A and B, there's nothing, so it's the empty set, and that's why you need to understand that concept and have that symbol for it. Okay, so now that you know everything about sets, let's do some examples. So for example 1, let's have 3 sets, A, B, and C. So we'll make A 1, 2, 4, 7, and 11. We'll make B 2, 4, 6, 8, 10. And let's make C 1, 3, 5, 7, and 9. So let's practice all these operations that we learned. So if we do A union B, remember that's any number that's in either set. So that'd be 1, 2, 4, 6, 7, 8, and 10, and then 11. If we do A union C, that'll give us 1, 2, 3, 4, 5, 7, 9, and 11. And B union C will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now let's do those intersections to see what happens when it has to be in both. So A intersect B is going to be much smaller. It's just 2 and 4. A intersect C is just going to be 1 and 7. And then B intersect C is the empty set, because there's no number that's in both of those. Okay, let's look at example 2 now. So let's let A be the set of all x such that x is a positive number that is less than or equal to 20. Then let's define B as the set of all numbers x such that x is a positive number, but it's odd, and it's less than or equal to, let's do 19. Then for C, let's say C is the set of all numbers x such that x is a positive number, 21 or less, and divisible by 3. Okay, so now we're using this set builder. And so we'll take those set builders, convert them to roster, and then do the same practice. So A is going to be all the numbers from 1 to 20. You can use that ... to signify that the pattern continues. B will be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. And then C will be 3, 6, 9, 12, 15, 18, and 21. Okay, so let's practice those operations. So A union B is going to be A. So this is where you get some shortcuts, because B is a proper subset of A. So since B is a subset of A union B is going to just be A. A union C, on the other hand, is going to be 1, 2, 3, 4, 5, 6, all the way up through 19, 20, 21. Then when we do B union C, what we will get is 1, 3, 5, 6, 7, 9, 11, 12, 13, 15, 17, 18, 19, and 21. Okay, so A intersect B is B, Again, because B is a proper subset of A. So the only numbers they'll have in common are the numbers that are in B. A intersect C will just be 3, 6, 9, 12, 15, and 18. And B intersect C is just going to be 3, 9, and 15. See? So now you're pros. So that's really all that there is to the basics of number sets and how sets work together. In the next lessons in this series, we'll delve more into that and what it teaches you. If this was helpful to you, please like the video, subscribe so that you'll see our new content. And always remember that if it's math, we have the solution.